Have you ever wondered how uncontrolled circulation can ripple through a system? It might seem like a random, chaotic process, but beneath the surface, there is a fascinating mathematical model at play. Today, we delve into the heart of this model, exploring how it works and how it helps to explain the world around us. Picture a pond, still and calm. Suddenly, a pebble breaks the surface, sending circles of ripples across the water. This is a simple but powerful metaphor for uncontrolled circulation. The pebble is a single event. The ripples are its effects spreading outwards. Now, imagine if we could predict the size, speed, and direction of those ripples based on the pebble's size, weight, and the force with which it was thrown. That's what this mathematical model allows us to do. At the heart of this model is a concept known as differential equations. These are mathematical equations that describe the rate of change of a quantity. In our pond metaphor, the differential equation would describe how quickly the ripples spread out from the point where the pebble hit the water. The first step in creating our model is to define the variables. The size of the pebble, its weight, and the force with which it was thrown are all variables that can affect the ripples. We represent these as x, y, and z in our model. Next, we need to determine the relationship between these variables. This is where the differential equations come in. For example, we may find that the speed of the ripples v is proportional to the size of the pebble, x, and the force with which it was thrown, z, but inversely proportional to its weight, y. This relationship can be represented as a differential equation, dv dt equals kx y, where k is a constant of proportionality, and dt is the change in time. Once we have our differential equation, we can use various mathematical techniques to solve it. This might involve integration, substitution, or another method, depending on the complexity of the equation. The solution will give us a function that describes the behavior of the ripples over time. In conclusion, the mathematical model of uncontrolled circulation involves a series of steps: defining variables, establishing relationships via differential equations, and solving those equations. It's a fascinating process that allows us to predict and understand the spread of effects from a single event, whether that's a pebble hitting a pond, a rumor spreading through a community, or a disease proliferating in a population. Remember, the beauty of mathematics lies not just in the elegance of its equations, but also in its power to model and predict the world around us. The next time you see ripples spreading out in a pond, think about the mathematical model behind it. It's a reminder that beneath the surface of the world, there's a world of mathematics waiting to be explored.